Hey everyone, in this video we're going to learn about our families of functions, specifically our parent functions. We're going to be able to recognize them by the equation as well as the graph and looking at some specific key characteristics of each. The first question you should be asking yourself is, well, what is a parent function? And a parent function is just a set of basic functions used as building blocks for more complicated functions. Our first parent function you should be very familiar with from Algebra 1, and that is our linear function. So our linear function looks like this. This is the equation y equals x, just our basic linear equation. Now you should remember from Algebra 1 how to graph this, but just in case you don't, I'm going to show you how, as well as look at some key characteristics of the equation and the graph. So we're going to make a little XY table, and we can pick some points on our X side, that's our input side, and then when we plug them in, we can get our Y values. So I'll show you by hand here. So instead of just having X, we have -2. So what's the value of Y? Well, it's -2. The same thing's going to happen with -1. We get out -1, get out 0, we get out 1, we get out 2, and now we can look at our graph. So -2, -2, there's a coordinate point, -1, -1, 0, 0, 1, 1, 2, 2, and we see we have this nice line here. So how are we going to recognize that it's a linear equation? Well, the highest power of x is 1. Okay, if you have any higher power like x squared, x cubed, it's no longer linear. Okay, how do we recognize the graph? It's just going to be a line linear. Very simple. Our second parent function is our absolute value function. All right, our absolute value function, the parent function looks like this, y equals the absolute value of x. All right, so we're going to graph this. Again, we're going to choose those same x coordinates. Now, when you take the absolute value of a number, you're just asking yourself, how far is that number away from 0? So if I plug in -2 into this function, well, how far is -2 away from 0 on like a number line? Well, it's 2 units away. All right, so whenever you plug in a negative number into an absolute value bar, you should get out a positive number. Okay, so same thing happens with -1, but of course with -1, your output is going to now be +1. 0 is 0. Now when you put in a positive number into an absolute value, you still get a positive out because 1 is 1 unit away from 0 and 2 is 2 units away from 0. So let's look at our graph here. We've got -2, +2, -1, +1, 0, 0, 1, 1, and 2, 2. That's going to create this graph right here. Okay, so how are we going to recognize our equation? Has to have the absolute value bars. Okay, that's me being lazy and just putting the bar symbol there, but it has to have absolute value bars. If it doesn't, it's not an absolute value function. All right, our graph should be V-shaped. Our next function that we're going to look at is our quadratic function. So the parent function for that is y equals x squared. I think a square is a quadrilateral, so quadratic. So let's plug in our usual suspects here. When you plug in -2 into this function, -2 squared means -2 times -2, which you should know comes out to be +4. -1 squared is +1, 0 squared 0, 1 squared is 1, and 2 squared is 4. So there's our coordinate points. -2, +4, -1, 1, 0, 0, 1, 1, and 2, 4. We get this U-shaped curve. All right, so how are we going to recognize our equation? The highest exponent should be 2. Okay, if you have anything higher, it's no longer quadratic. How do we recognize the graph? It's U-shaped, and you should know that this U-shaped graph is called a parabola. All right. Our next parent function is our square root function. So our square root parent function looks like this. Y equals the square root of x. Okay, so let's plug in our normal stuff. Now, if you go to your calculator, or if you just remember from Algebra 1, I can't square root -2 and get a real number. It doesn't exist. It's undefined. Okay, same thing with -1. I can't square root a negative number and get a real number out. So we're just going to get rid of those. Okay, um, so the square root of 0 we can do, it's 0. Why? Because 0 times 0 is 0, so the square root of 0 is 0. Square root of 1 is 1. Now, we can do the square root of 2. We could use our calculator and get a decimal, but we want to get some nice pretty points for these basic graphs. So let's go up to our first perfect square after 1. So 2 times 2 is 4. So the square root of 4 is 2. And now we have some points. So we have 0, 0, 1, 1, and 4, 2. We have this kind of curve going on. So how are we going to recognize the equation? Well, it has to have a square root symbol. Again, I'm being lazy and not writing the word square root symbol. All right, how are we going to recognize the graph? Well, first of all, notice there's a definite starting point right here, okay? And depending on the function, that's going to change, but there's definitely a starting point, and then it's going to go off in one direction. So it's a one direction curve. Some people say it kind of looks like an eyebrow. I like to think that it looks kind of like the square root symbol in a way. I mean, minus this part, but you kind of see that curve going on in your graph. Our next function is cubic. So a cubic function, parent function looks like this, y equals x cubed. Okay, let's look at the xy table. So we got -2, -1, 0, 1, and 2. -2 cubed means -2 times -2 times -2 when we plug it into the function. We get a +4 times -2, we get out -8. -1 cubed, -1 times -1 times -1 is -1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. If I'm ever going too fast, feel free to pause the video, try it yourself, and then play it when you're ready. So here we go, -2, -8. It's going to go off of our graph a little bit, so I'm just going to kind of estimate. -1, -1, 0, 0, 1, 1, and 2, 8 again will go off of our graph, but we can see this curve that has formed. All right, that is our cubic graph. So how are we going to recognize the equation? The highest power is 3. Okay, how are we going to recognize the graph? Well, it definitely should have opposite end behavior. So that means when you're looking at your arrows of your graph, they should be going in opposite directions. One should be going down and one should be going up, or vice versa. Our next graph is our cube root function. It looks like this, or the equation does anyway. Y equals the cube root of x. So let's again, use some of our common numbers, except I'm going to start with the positives first. All right, the cube root of 0 is 0. Why? Because 0 times 0 times 0 is 0. The cube root of 1 is 1. Okay, those are nice points. Now, cube root of 2, you can definitely get that on your calculator. It's going to be a gross decimal, but we want to get some nice points here for ourselves. So our next perfect cube is 8, because 2 times 2 times 2 is 8. So the cube root of 8 is 2. Now, unlike your square root function, you can take the square roots of negative numbers. So the cube roots of negative numbers. The cube root of -1 is -1, because -1 times -1 times -1 is -1. And the cube root of -8 is -2. So now we have some points for our graph. Again, we're going to have to estimate here, go out to -8 and down -2, -1, -1, 0, 0, 1, 1, and then 8. 2. So you're going to notice this looks very similar to the cubic function, except now it's been turned on its side. So how are we going to recognize the equation? Look for a cube root symbol, right? If you see that, it's a cube root function. All right, how are we going to recognize the graph? Again, it's going to have opposite end behavior. But this time with our end behavior, it's going to be going left and right, or right to left. All right, our next function is our rational function. The way I like to remember the rational function is fractional. So our basic function is y equals 1 over x. All right, we're going to plug in our usual numbers here. Now when you plug in -2 to this function, you get 1 over -2, or -1/2. When you plug in -1, 1 over -1 is -1. Now here's something you need to be aware of. Well, 1 over 0. If you plug that into your calculator, you're going to get an error. That's because it's undefined. You cannot have a point there. You can never divide by 0, and that's something you need to know. All right, when we plug in 1, 1 over 1 is 1, and 1 over 2 is 1/2. So now we have some points. So -2, -1/2, -1, -1. We know that there's like this skip of some sort at 0. We have 1, 1, and 2, 1/2. Now, it would probably help you to get a few more points, because right now you're like, what is that going to look like? So if I plug in -3, well, 1 over -3 is -1/3. -4, -1/4, -1/5, -6. You'll notice that we're getting closer and closer to the x-axis. Now, if I plug in, say, -1/2, 1 over -1/2, when you divide by a fraction, you keep change flip and it becomes -2. And then we keep going, and we get closer and closer to this y-axis. So actually what's happening here at the y-axis and at the x-axis is something called an asymptote. We have a vertical and a horizontal one here, and it's going to be the same on the other side of those asymptotes. So with the equation, you should be able to recognize it as a quotient of two polynomials. Okay, also just think that the x is in the denominator. Okay. For the graph, you're going to typically have asymptotes. So those lines, sorry, I want to spell asymptotes correctly. It's A-S-M, or A-S-Y-M-P-T-O-T-E-S. And you're going to have multiple curves. Okay, it's kind of our weirdest looking function if you think about it that way. All right, last two. So we have an exponential graph. So for an exponential parent function, it's y equals a to the x for kind of our basic there. And the a is just going to be some number. All right, so for our specific example, we're going to use y equals 2 to the x. So we're going to use our typical numbers, -2, -1, 0, 1, and 2. So when you plug in -2, y equals 2 to the -2. You plug that into your calculator, you should get out 1/4 or 0.25. Okay, we'll look at that more specifically when we get into our exponential unit, but for now we can just use our calculator. 2 to the -1 power is going to be 1/2. All right, now here's where I need you to remember. Anything to the 0 power, whether it's 2 to the 0 power or 1,000,000 to the 0 power, anything to the 0 power is 1. That's a key point you need to be aware of for exponentials. 2 to the first is 2, and 2 squared is 4. So let's plot those points. So -2 and 1/4, we go up just a little bit, -1.5, 0 and 1, 1 and 2, 2 and 4. So an exponential graph, and we could keep coming up with points on the left or the right, it's going to look like this is our basic exponential graph. There's actually an asymptote, a horizontal asymptote right there. And again, we'll talk more specifically about these as we go through our units, but for right now, this is enough information. So how do you recognize your equation? X is in the exponent. Okay, if the x isn't in the exponent, it's not exponential. How do you recognize the graph? It's going to be just a curve going in both directions, and you typically have a horizontal asymptote. Okay. And our last function for today, logarithmic. So y equals log of x. Unless we see some other number right beside the log, we assume that it is in what we call base 10, which is what we're working with today. All right, so let's graph it. We're going to use our calculator here. We're just going to start at -1, 0, 1, 2, and then I'm going to make a jump to 10, and you'll see why in just a minute. So if you plug into your calculator, because you definitely need calculators for logs, the log of -1, you're going to get an error. That's because it's undefined. It's also undefined at 0. But then the log of 1 is 0. And this is a key point I need you to remember. Now, the easiest way I know to remember that 1, 0 is a key point for the log function is because if I look at the word logarithmic or just log, I can put a comma here in parentheses there, and it looks like 1, 0. So that's a key point. The log of 2, plug into your calculator, you're going to get a very small decimal of 0.301 about, and then you're going to keep getting small decimals until you get to 10. The log of 10 is 1, and this is another key point that I want you to be aware of. So let's graph those points. So we have 1, 0, 2, and then a little bit more, you know, and then we go all the way out to 10, and then it's finally up at 1. So we have kind of this curve, but it's not like the square root curve because it actually keeps going. It gets closer and closer to that y-axis, but it doesn't cross. That's because there's an asymptote there. So I could have plugged in a bunch of numbers in between 0 and 1, some decimals, and I would have seen that pattern go on. So how are we going to recognize the equation? It's pretty easy. It has to have the word log. If it doesn't have the word log, then it's not logarithmic. How are you going to recognize the graph? Again, it's a curve, just like the exponential, except it has a vertical asymptote. So please bring your notes into class, bring any questions you have, and we can talk more about these graphs in class together.